I think this is recording. Let's take a look at this problem. They give us two functions f and g, and they ask us to find the domain of this new function if you take the product of f and g, and these new functions if you take the quotient. So we're going to have to, in every case here, find the domain of f and the domain of g. So let's start out by doing that. The domain of any function is the set of all real numbers, excluding any values that cause division by 0 and excluding any values that would cause us to take the square root of a negative number. We don't have any variables in a denominator, but we do have a variable underneath a radical, underneath a square root. So if we took too much away from 15, it would be negative. So we need this 15 minus x to be greater than or equal to 0. So that means that we need x to be less than or equal to 15. If x were bigger than 15, you'd get a negative value. You'd be taking too much away from 15. So written in interval notation, the domain of f is equal to negative infinity to 15, including 15. So let's make a sketch of that on a number line. I'm going to include 15, the endpoint 15, and shade to the left. So all of these values are in the domain of f. Let's figure out what the domain of g is. So it's a similar idea here that this x plus 8 has to be 0 or positive. So if x were less than or equal to negative 8, it would be 2 negative, and you get a negative sum. So x has to be greater than or equal to negative 8. So the domain of g includes the endpoint negative 8 and is to the right of negative 8. So on a number line, we shade to the right of negative 8. So if we now want to find the domain of fg, we intersect these two sets. So the domain of this new function that you get through multiplying f and g together is the domain of f intersected with the domain of g. So that might be found easiest by making a quick sketch, recognizing that our points of interest are negative 8 and positive 15, and negative 8 in each of these is shaded. So to be in our intersection, it has to be in this set, and it has to be in this set to be in this domain set. So 15 is shaded in each of these, so it's shaded in our intersection. To the left of negative 8 is not shaded in the second set, therefore it's not in the intersection. And to the right of 15 is not shaded in the first set, therefore to the right of 15 will not be shaded in our answer. But between negative 8 and positive 15 is shaded in both. It's shaded in the first one and it's shaded in the second one, therefore it's in our intersection. So our final answer for part A is the domain of this function fg is from negative 8 to positive 15, including those endpoints. Now, we don't know if our answer in part B will be the same as this. We do know that it will be the same, or it will have some additional restrictions. I'm going to move this off to the side. I really won't need it to find my answer for part B. So now, with f over g, I have the domain of f intersected with the domain of g, and I have to be concerned that this function g of x that's in a denominator, could it ever equal 0? So I temporarily let g of x equal to 0, so I know what to avoid. G of x is the square root of x plus 8, which means that if x is equal to a negative 8, then g evaluated at negative 8 is equal to 0. And we can't let that happen because g of x is in the denominator. So g evaluated at negative 8, we never want that g to be 0. Therefore, we never want x to be negative 8. So this set that prevents g of x from being 0, that's the set of all real numbers excluding negative 8. So to be in our intersection of these three sets, you have to be in every set, this set and this set and this third set. So this intersection, our points of interest here are negative 8 and positive 15. And we can see that 15 is shaded in all three sets, therefore it's shaded in the intersection. Negative 8 is not shaded here, so it will not be shaded in the intersection. To the left of negative 8 is not shaded in one of them, so it will not be shaded in the intersection. To the right of 15. But in between negative 8 and positive 15 is shaded in all three of them. It's shaded here, and it's shaded here, and it's shaded here. So our domain for f over g is from negative 8 excluding negative 8 all the way to positive 15. Notice that it is different than our previous answer. We knew that it was either going to be, that it could have been the same, or the idea was that it was going to add an additional restriction, and what it ended up doing was just throwing out that left endpoint. So you can see how similar the answers are, but they are different. All right, so let's continue on to this part C, and once again we want to intersect the domain of f with the domain of g, but we also are concerned that this denominator could equal 0. So f of x is the expression the square root of 15 minus x, and we do not want this expression to equal 0 because it's in a denominator, but we temporarily let it equal 0 just so that we can solve the equation. And this solves to x is equal to 15, which tells us that f evaluated at 15 is equal to 0. We need to avoid that because f is in a denominator. So to avoid getting a result of 0, we have to avoid the input of 15. So the set of values that that avoid f of x from being 0 is the set of all real numbers excluding positive 15. Any other value that we pick will result in something that's not equal to 0, and that's what we're trying to describe as all the numbers that are not equal to 0. So this intersection of these three sets is going to be the domain for part C. Let's make a sketch of this and then describe it in interval notation. So the points of excuse me, the points of interest in all three of these, the endpoints, or like I say, points of interest, are -8 and +15. -8 is shaded in all three of these sets, so it will be included in the intersection. +15 is excluded from this third one, so it's excluded from the intersection. To be in the intersection, you have to be in all three sets, and it's only the portion here in the middle that's in all three sets. To the left of -8, here is missing, and to the right of 15 in the very top set there, it's missing. So our domain of this function g over f includes the endpoint -8 all the way up to 15, excluding 15. So once again, it's not the same as the answer in part A, but it was very similar because we knew that it was going to be either equal to that answer exactly or have additional restrictions. And that's what ended up having. It had the additional restriction that 15 caused division by 0, so we had to throw that out. So here's a comparison of the domains for A, B, and C for this problem. Hope that helps, and I'll talk to you later. Bye.